Great. More people are coming in. Welcome. Although we are, although I am based in Portland on the West Coast of the United States, I do like to begin punctually. So I'm happy for us to get this show on the road today. We have an amazing guest, Benoit Boré from our team, Serverless Guru. They're going to be talking about how to optimize AppSync with DynamoDB Single Table Design, which is such a fantastic topic. I think this needs to be talked about more, just from what I'm seeing on the operational efficiency side, the technology growth side. This is a really important topic that people should be aware of. Benoit, I say, is one of the masters that I know of AppSync, and so I'm really happy to sort of get him away from some of the busy work that he's doing. For y'all who don't know me, I am Joshua Proto. I am COO of Serverless Guru, co-host of Talking Serverless and the Serverless Economics podcast, AWS community builder. Accolades. And this whole sort of community information is sponsored by our company, Serverless Guru. We're a serverless first consultancy, and so if you have any problems or questions related to the implementation of your serverless technology or trying to figure out the best use cases for serverless in your business, that is what we're doing every single day for companies across the world in many different verticals. And that sort of thing. So if there's any other questions that you have post this webinar, please feel free to reach out to us at serverlessguru.com. Then you can have your own personal meeting with Benoit, like I get to have right here, right now, which is super fun. And we can talk about how to just sort of make your business and make your life easier using serverless technology. So I think that's everything I have to say. Some quick housekeeping things is, this will be about an hour, including questions and answers. And if you have any questions that come up throughout this, please feel free to put them in the chat or the Q&A section. I will be handling the chat, so Benoit just gets to focus on the presentation and that sort of thing. But please feel free to send any information or feedback or questions in the chat, and we will get to them as we go throughout the presentation. And with that, Benoit, I will hand it over to you.
All right, thank you, Josh. So welcome everyone. Good morning, good afternoon, good evening, depending on where you are. Maybe just a few words about me first. I am a serverless developer at Serverless Guru, and I've been a user of serverless since around 2018, where I started to be a bit more active in the community, especially in the AppSync community. And I'm actually a contributor and maintainer of the serverless framework, AppSync plugin, and the simulator. And you can find me on GitHub and Twitter, and also my website my blog, where I talk a lot about serverless and AppSync in general. And 2 fun facts about me: I love cats, and I drink a lot of matcha tea. All right, with that. Let's start maybe with a quick introduction to AppSync. I will assume that you all know what it is, but AppSync is obviously a service by AWS for GraphQL, creating GraphQL APIs. It's fully managed, and of course, it's serverless. This is what is most exciting about it, meaning that you won't pay for either time. You will pay only for the requests that your users do. And of course, it scales. You can scale to thousands or millions of requests per day without any problem, and you won't have to worry about it. AppSync core feature is based around data sources, and most of the time in a serverless architecture, these data sources will be DynamoDB or Lambda, but you also have other data sources such as Elasticsearch, HTTP, and even None, which is a local resolver that allow you to do a lot of exciting things, but that may be another subject for another webinar. Another great feature about AppSync, it supports subscriptions, which is a really cool feature, allowing you to react to some real-time events in your application. And finally, caching is also one great feature about AppSync, allowing you to cache full requests or even part requests, some resolvers, so that your API is as snappy as it can be. DynamoDB, what it is, again, a very quick introduction. I will assume that you also know what it is, but it's a key value store for data. It claims a single-digit millisecond latency. It's highly scalable, millions of requests per second without any problem. And of course, it's serverless, meaning that you will also not pay for idle, or if you don't get any requests, you won't pay for anything. Single table design. I like to define it as the art of storing your data in a manner so as to make it easily and quickly accessible to your application. And the way you do that is by pre-joining and denormalizing data. I won't go into details about single table design. There are other people much more qualified than I am to talk about this. But today we're going to talk about how you can apply single table design patterns in AppSync. So there are basically three ways you can integrate DynamoDB with AppSync. And first, let's go back a little bit and talk about other ways you can use AppSync with DynamoDB without using single table. And the first and is the easiest way to do it is to have multi-table in your application, meaning that one table will be one entity. And this is a great way to, an easy way to apply DynamoDB patterns in AppSync, because then you can match one table to one type in AppSync, right? So, which means that one resolver will always be one DynamoDB query, and it will resolve one entity. And by one entity, I mean one item type. It could be one user or several users, but you will not resolve user and orders in the same resolver. This way of doing it is very simple because each resolver only cares about one item, one entity, one query, which makes your mapping templates very simple and very straightforward. Usually it's just one query and nothing else. A key aspect to that is that what is performing the join operations then becomes AppSync. For each resolver, you will receive a source that AppSync provides you, and you will get, in a way, the foreign key from the previous resolver, and you will resolve all your relations through that. So yeah, as I said, this is how AppSync can act as the glue for your data. One downside to that is that it's a bit less performant. You cannot, because you're using multi-tables, you cannot use single table design benefits. And also, because all your resolvers in AppSync or in GraphQL will be executed in a sequence, it means that it can make the response time a bit slower because they all have to be executed one after another. And if I'm not mistaken, this is for those who are using Amplify, this is the default way of doing AppSync with DynamoDB for Amplify. Then a second way you can use DynamoDB with AppSync is by leveraging single table design, but in AppSync, you will consider it as multi-table. So one table contains multiple entities. One resolver will still be one DynamoDB query and will still resolve one entity. So your data might still be grouped together in Dynamo, but AppSync should not worry about it. The advantage of this is that your resolvers and your mapping templates will remain simple as if you were using multi-table. But in other aspects of your application, you still can leverage single table design patterns to get the benefits from single table design. And I'm thinking about maybe cron jobs or Lambda functions that run in a background process, some SQS worker maybe. So you still get single table design benefits for your application, but you keep your AppSync design very simple. Finally, and the subject of this webinar is going to be about this, is by using single table design also in AppSync. So again, one table contains multiple entities, and one resolver will execute one DynamoDB query, but this time you will get multiple entities from one single query. So let's take an example. If you had a user and you want to also get the user's orders, you could get all of them together and return it to your GraphQL client. So here you get the benefits from single table design also in AppSync. One downside to this is that resolvers and mapping templates can grow in complexity. It also has some limitations, but we'll talk about that just in a few moments. So I'd like to go and show you a quick demo. Imagine, can you see my VS Code?
Yes.
Yeah, awesome. Imagine that you have this schema where you have a GetUser and GetUsers endpoints, and these users have a name, they have an email, and they get also one or several orders. So the way you can do that and get the user and the orders at the same time in one single DynamoDB query is by by grouping them into the same partition. And let me show you what I mean. I go over to my DynamoDB table here, and you can see that my user is here, and the order are here as well, under the same partition key, except that each item has different sort keys. So we have the user here and the order that are sorted by date. And another thing to notice here is that I have in my schema, in my DynamoDB schema, I have an entity which defines and tells me which type of item I'm using. All right. So if I go back to code, this is a query that will return all these three items in one single query. So I'm using a condition expression here that fetch the primary key as being the user. There's a prefix user here, plus the ID of that user. And if I go to the response template, this is where the magic happens. So the first thing we do here is by looking at the size of the response from DynamoDB. If it's 0, it means that we didn't find anything. And that probably means that the user doesn't exist, or there's just no data. So in that case, what we do here is that we just respond with an error saying user not found or data not found. If we do find something into DynamoDB, then we have to do some data transformation, because DynamoDB will return all the data in an array, but they are all in a flat array. They are not structured as our AppSync endpoint is expecting it, right? So by iterating over that array, we first can check and find which items we are finding through the entity attribute. So the first thing we look for is the user. And once we find it, we just keep a reference of it. And we also add an orders attribute as an empty array. And then as we keep iterating over that array, we find and we look for the orders, which we are going to add to that empty orders array back into the user. So in this way, we are formatting the data that we receive from DynamoDB to the schema that is expected by AppSync. Basically, this schema. So we do get the user, the name, the email, and then we go and move the orders inside the orders array, right? And once this is returned by AppSync, the user would get the expected format. And let me actually show you that. So here I'm in the console for AppSync, and I have a query that I prepared. I'm getting the user with an ID 1, and if I execute it, you will see that I get the user with its name, the email, and all the orders. Okay. Now, let me re-execute that. Let's go and see what happens under the hood. For that, we can go into CloudWatch. All right. So this is actually a very good feature of AppSync. If you log all your requests, you can see everything that happens in your mapping templates, in the request, in the response. And this is very useful for debugging, and also for me to show you how it works here in the background. So as you can see here, I have my request mapping that got interpreted by AppSync. So my VTL template got translated into a DynamoDB request, and we can see it here. It's a bit hard to read because it's stringified, but you can see that the operation is a query. We are scanning backwards because I want the user and the latest orders. So that's the way I arranged my items into my DynamoDB table. And we are looking for the PK, which is user #1, right? So that goes to DynamoDB, and DynamoDB responds with an answer, which we can see here. So as you can see, as I was explaining earlier, all the items come in a flat array. So we can first see here my user and 2 orders. And then the response template that I showed you earlier is what reformat everything, and it returns it to AppSync. And you can see here that we have the user ID, the name, and the orders got here embedded into the user entity, right? So this is how we get the user and the orders in one single query. I can actually show you. If we go into X-ray, we can see that we execute only one DynamoDB query right here. So you can see that we have the query.getUser resolver that got executed, and there's one DynamoDB query here, and nothing else. So we do not need here to have two resolver, and then I have one specific resolver for the orders. Okay. Next. Now, one problem with that, and this is actually one of the first traps that one can fall into, is oh, sorry, shouldn't have done that. Okay. One of the powerful feature of GraphQL is that you can specify which fields that you want and which ones you don't want. This is called avoiding to underfetch or overfetch. So if I wanted to, here, I could say, I only want the ID, the name, and the email of the user. Sorry, I will have to redeploy the previous version because I shouldn't have deployed again because I need to show you first how it's not working well. So let's wait a few seconds before it redeploys. So basically what we want to avoid is that when a user, well, a client requests only the ID, the name, and the email of a user, we do not want to get the orders. What would happen, and that I will show you, is that when we do not select the orders in the request, one problem we have with the current design is that here we always fetch with the PK of the user, so we will always get users and orders. So let me demonstrate that. Now I'm going to execute this request, which only requires the ID, the name, and the email. And let's go and see what happens in CloudWatch. Right. As you can see, the request is the same as before. We still use the PK as user, and DynamoDB responds with all my items. And in the response template, we also return the orders with its total, the IDs, etc. Then what happens is that AppSync will see that the user did not request the orders field, so it will just strip it out. But as you can see in the scanned count here, we still have queried all these items from DynamoDB, which could result in a waste of RCUs and spend of money, basically. So in this case, we avoid overfetching in the client, but our backend still is overfetching in a way. So is there a way we can fix this? Well, luckily there is. So one way to do this is by looking at the context info that AppSync provides us, which tells us which selection set has been requested by the client. So what we do here is that we look that if the orders field has not been requested by the client, we will add a condition expression where we say that the sort key starts with or is the user sort key value. So by doing that, DynamoDB will only return basically one element, which is the user itself. So let me show you what I mean. So let's execute this query again. I redeployed the new code implementing this check. So if I go now to CloudWatch, we can see that we are looking for the PK being user1 and the SK being user1 as well. And in the response from DynamoDB, we can see that this time we got only the user item and the scan count is back to 1. Okay. So this is how we can avoid overfetching from DynamoDB when the client does not request this value, right? But now, imagine that we wanted to also implement this GetUsers endpoint, and we can do that by creating a new resolver, which is GetUsers, query.getUsers. And what we do here is that we can look into the PK and we look for the entity, which is the value user. And basically, this is a global secondary index that I have that will return the users, only the users. Let me show you what I mean. So if I go back to my data here, I have a GSI1 on the entity attribute, and it will return the users. So if I now go to my query here, and I want to get all the users and their orders, let's see what happens. I get null. And the reason for that is that in my access pattern, in my GSI1 access pattern, the orders do not live under the same partition. They are not grouped together with the users. So by implementing single table design on the GetUser singular resolver, we broke or we do not have a functional GetUsers endpoint. And the way we can fix that is that we can just add a new resolver to the user type to resolve the orders. So the way I can do that is, as I said, if I get a user.orders resolver, I can look for the entities that are under the user one, in this case, partition, and the SK starts with order. So in this case, I will only get from my main index, I will only get the entities that are under the user partition, but only for the orders. So let's wait a few seconds before it deploys, and let's see if that works. Okay. So now if I re-execute this query, I should see the orders to be fulfilled. Yeah, indeed. So in this case, then, because my pattern does not allow to get several users at once and their orders, I have no choice but to use two resolvers. First, resolve the users, and then for each user, resolve the orders. And again, if I go back to CloudWatch, we can see that here, you can see that this is my first resolver that goes and check in the GSI1 all the entities that belong to the user type. And in the response, I do get all my users. In this case, I only have one, but I could have 2, 3, 10 maybe. But then we're missing the orders. But we have a second resolver for that, which is fetching the orders for each user using the source. As you can see, the source here comes from the previous resolver, and using the ID from the previous resolver, I can query all the orders for that user. And in the response, I can see I have them here. Okay. This works great, but now I have another problem. In AppSync or in GraphQL in general, when you create a resolver for a type and field, in this case, the type is user and the field is orders, it applies to all endpoints that return this kind of type. This means and includes my my GetUser endpoint. So let's execute this query again and see what happens. I just executed the query, and let's go and see in CloudWatch what happened under the hood. All right. So as you can see, this hasn't changed. We still query on the PK being user one, and the response is again still my user and my orders. And then my my response template just reformat everything as usual, as we expected before. But if you look here, you will see that the GetUser orders gets re-resolved. So it means that we will execute an extra query to resolve the orders again, meaning that we are actually fetching the orders twice. In this case, this is not what we want. And this is actually another aspect, another thing that is easily, that you can easily forget and and that can break all the benefits from single table design in AppSync. So we are resolving the orders twice here. And to demonstrate that, I can go into X-ray again. You can see that we did resolve the query dot get user, which went into DynamoDB. But again, here in the user.orders, we also do a DynamoDB query. And this is where the orders get resolved again. And you can see here that we do have 2 DynamoDB queries. How can we fix this? Is there a way we can fix this? Yes, fortunately, yes. So if I go back to my code, and let's go to version 2.2. Another great feature about VTIL templates in AppSync is the return directive. It's a very useful method that you can use when you want to early return in the resolver. So in this case, what we want to do is we want to check that if in the source the orders come already resolved, then we don't need to resolve them again. This is going to be the case in the GetUser endpoint, while in the GetUsers endpoint, they won't be resolved, so we do want to resolve them. So when we find them, we can return and return them immediately. And this will completely short circuit the resolver and the DynamoDB query, meaning that this query will not be executed at all. So I'm going to demonstrate this to you. Let's re-execute this query. So again, I'm executing the GetUser query, including the orders. And let's go back into CloudWatch and see what happens. Okay, so again, this hasn't changed. We still resolve our user and its orders into one single query here. But then if we look at the user.orders resolver, we can see that in the source, we have the user and its orders are already resolved. And here, the return directive kicked in and it's early returned the orders that were previously resolved from the previous resolver. And if you look right after here, there is no response template log, which means that it was not executed at all. And to demonstrate this and to prove it to you, I would go back to X-ray. And here you can see that the query GetUser got executed, which resolves the user and the orders. And there is no user.orders resolver. And you can see here that in the DynamoDB request, we only have one query that was executed. This proves that the second query was completely skipped and not executed. So we fixed the issue that we created before. All right, let's go back to the slides. So when you want to implement single table design in AppSync, there are a few gotchas that we just demonstrated that you need to remember. First of all, it's very easy to overfetch. As I showed you in the demo, if the client in AppSync doesn't require some fields, then you don't need to fetch them from DynamoDB. Otherwise, it's just a waste of resources and a waste of RCUs. And I just show you how you can avoid that. Also, it's very easy to break other endpoints, and I just demonstrated that as well. So when you create a resolver, you constantly need to remind and to remember which impact it can have on other resolvers that already exist. And one more thing I would like to add about this is that you should always be careful about DynamoDB limits. For instance, the 1 megabyte limit. In our case, back to the user and your orders example, if your user entity is very big, close to the 400 kilobytes, maybe, and the orders are very big as well, you might end up missing some data. And it's very important to remember, because in the response mapping, in the response template, when you have to reformat everything and put everything together, if you are missing something, for instance, you are missing the user entity, then you just cannot rebuild and reformat everything together. So that's something very important to remember. Okay, maybe a few words about when it's a good idea to use single table design with AppSync and when not. Usually a very good example and a very good reason to use single table design with AppSync is when you have bounded relations. An example for that would be if you have a to-do application where you get a to-do list and then a list of tasks. Maybe you will have 5, 10, 20 tasks at most. So the number of relations is very limited and usually very small. So it's a very good use case to try and optimize your query to get everything at once, so that the response is as fast as possible. Another example, and this is a bit like in the demo, when you want the first and or last end relations. So for instance, if you wanted the user and the last 10 orders, well, in this case, the orders are unbounded, but if you only want the last 10, well, it is bounded in the end. So it also can work very well. Another case that you might want to consider using single table design is when you have multiple relations, but they have to be bounded. So for a user, you might want to get the user, his emails, his phone numbers, his addresses. These would usually be very bounded. So you could get just all of them at once. Here you could also, of course, store them into the user entity itself if you wanted to, but if they are in different items, that can work very well as well. On the other hand, what doesn't really work well is when you have unbounded relations. You just cannot have a query that gets a user and all his orders. It's maybe more of a DynamoDB as well limitation, because you would have the 1 megabyte query limit. It might not also be a very good idea to just get all the orders at once. But in a normal application, like in Lambda or something, what you could do is like have a pagination process that will go over all the DynamoDB pages using the next token ID. But in a AppSync resolver, you just cannot do that. So it's not something that you can do. Of course, if you have several unbounded relations, so back to previous example, if you want the user, the last 10 orders, and his emails and his phone numbers, well, in your DynamoDB table, these items will not be together under the same partition. Well, they might be, but they won't be close together enough so that you can query them all at once. So in that case, you will have to use resolvers as you could do as usual, right? Deeply nested relations. What you could do is if you wanted to, you could have a hierarchical structure where your user and your orders and the order items, they all live under the same partition and they are in a hierarchical structure in the sort key. It's something you can do, but it's hard to control in AppSync because again, there is a risk of overfetching. If you want just the user and the orders, then you won't have enough with the 1 mega limits to, and you will be also wasting a lot of RCUs to read all the items. So it's usually not a very good idea. And finally, with paginated and filtered relations. So in AppSync, what you could do is have a query that is get the user and the order starting from the date, a given date. Well, these items, they won't be together under the same partition in DynamoDB. So it's not something that you can do and get them all at once. So in that case, you would also have to use different resolvers. Now, to the question, should you use it? I think that usually the answer is it depends. It really depends on your use case and on your knowledge also of your application. But a few pieces of advice I would say is that you should first think in terms of access pattern first and not try to build your access patterns on top of GraphQL, because GraphQL by definition is a powerful tool that allows you to query and fetch your data in a graph, but DynamoDB is not a graph database. So what you usually want to do is first think what your application will need and what are the queries that it will execute. Yes, you can in AppSync or in GraphQL, you can say, I want the user and the user items, the orders and the order items. And from the order items, I want the product description and the stock that I have. Yeah, you can do that, but in DynamoDB, you cannot get all that information in just one query. So also, chances are that your application will almost never do that. So in a read application, you will probably first get the user and the orders, then the user will click on an order, you will get the order and the order items, etc. So think first about these access patterns, and then you can define your DynamoDB access patterns. So it would be then user and orders, then orders and user items in a different partition or in a different global security index. Be aware of the gotchas that we explained earlier. Keep them in mind. And I would also say, don't try to over-optimize. It's related to what I said earlier. You can, in GraphQL, get all your data in one query, but don't try to stick everything under a partition just for the sake of optimizing AppSync. It might just not be worth it. Keep them simple, keep the resolver simple. And also, last but not least, remember that there's also probably other ways that you can optimize your AppSync endpoint. And one of them is using the cache functionality. So yeah, if you have a big query that gets a user and then the user orders and then the user item and then the products, you might execute it once. It might take some time, but then you can plug in the cache functionality, and all these resolvers response will be cached. And the next time the user will execute it, it would just be way faster. Right, that's it for today. So if you have questions, just yeah, let me know. And thank you.
Fantastic, Benoit. Thank you so much for this presentation and talk. I know I've definitely learned some things here. We did have one question. I think you may have handled that already, talked about it a little bit, but maybe you could elaborate a bit more about it if there's anything to elaborate, which is with AppSync, is it able to handle the paginations and send back the full result, or do you have to use the different resolvers like you were saying before?
Right, so resolvers cannot handle pagination. Yeah, no, in the case that you want pagination, it's actually the client that usually will need to paginate. So AppSync will return the first page and return a token that the client then can use to execute a new query and get the second page. Yeah.
Okay, great.
I don't know if that answers the question.
We'll see. I think that is satiating our questioner for now, which is great. If anyone else has any other questions, please feel free to. Yes, it did. Yeah, Daniel says it did. Perfect. If there are any other questions, please put them in the chat or the Q&A box, or if there's any questions later, we can definitely answer them asynchronously as well. And that sort of thing. You know, I'll potentially have one for you, Benoit, and someone who's using AppSync so much, I would ask, like, what if there was something that there was like an update or another feature or something to sort of improve the system or its sort of family of integrations, like what would that be in your mind? Like where do you think AppSync will go?
Yeah, well, I think that AppSync has a lot of potential. There are a few things that I would love to see implemented in AppSync very soon. One of them is maybe custom scalars, which is not supported currently. And I think there's a lot of requests about this as well. Another popular request is to support custom domains, because currently, unlike API Gateway, you cannot hook your own domain to AppSync endpoints unless you use a CloudFront CDN in front of it. But in that case, you would still be limited to simple queries and mutations, because I believe that CloudFront does not allow us to support subscriptions in AppSync through CloudFront. So maybe these are probably the most two popular requests for AppSync.
All right, fantastic. No, that's great to know. I know from like the AWS and the AWS partnership side, they definitely have a lot of resources around like their AWS AppSync specialty team, and they always seem to be working a lot and trying to understand what is it, just sort of new needed use cases. So, we'll be sure to tell them this is Serverless Guru's number one number one request potentially, or what we think could be very, very beneficial. So that's great.
Yeah. Any other question?
Let's see if there's anything else that will trickle in. But as of right now, that was the main question that we had come in. Oh, here we go. How to handle custom errors in AppSync from Dharmendra.
Right. Yeah. In AppSync, well, you have two ways of doing this. If you want to do it in a VTL resolver, there is a utility method that you can call that will return custom errors. The other way, if you're using Lambda, is just to throw an exception in your Lambda. But then you would have to catch it anyway in the resolver, and then call the same util.error method. Yeah. Usually, I would say to that, I would add that I try to avoid to make, when I'm using Lambda, I usually try to avoid making the Lambda fail when I want to return an error in AppSync, at least when it's a controlled error. For instance, if you want to have a functionality or a check in your Lambda function that checks that a user is authorized to access a given resource, you can throw an error. But the downside to that is that if your Lambda fails, it will show in CloudWatch, in the metrics, it will show as a failure of Lambda. When it's not really a failure in Lambda, it's more a failure of business logic, right? So I tried to avoid that. And instead, what you can do is return a specific format in your Lambda function that returns a payload saying, for instance, error is true, or given an error and the data. And if in the Lambda, in the AppSync response template, you see that in the payload there is an error, then you can raise the error in the resolver instead of Lambda. Because then your Lambda will not fail. It just returns the error instead, and then the error is handled by the resolver. Then, yeah, in your metrics, in your observability tool, Lambda will show as a successful execution, and it will not maybe pollute your statistics about failing Lambda and errors.
All right, great. That's good. Definitely a robust answer there. Let's see. We probably have time for one more question if someone happens to have one more question. Until then, I can just sort of say thank you so much, Benoit, for joining us and giving us talk. I know I definitely found it very useful, and now like this will go up across many of our public channels, and so a lot of people who weren't able to attend live will now be able to see this and learn a bit. Is AppSync the right should I be using this right now with the single table design, and be able to sort of delve into that it depends answer, that nuanced answer, which I think is really important, because at the end of the day, there are problems and there are solutions, and I could build an entire house with just a screwdriver and a hammer, but thankfully I have a drill and we have power tools and different bits and that sort of thing. So it's important to know the degree of the tools that you're using and when to use them. So this is super fantastic. I love talks like this. Awesome. Fantastic.
Well, if there's any other question, feel free to hit me on Twitter, or just contact Serverless Guru, and we'd be happy to answer them.
Fantastic. And Benoit, if people wanted to follow up with follow up with you specifically, what would be the best place for that? Is it your website? Is it your Twitter? Your email? What do you check the most?
Yeah, my Twitter would be the go-to point of contact, I would say. And if you want to learn more about AppSync and yeah, serverless in general, my blog could be a go-to as well.
All right. Fantastic. Fantastic. Well, with that, I think we'll definitely wrap. So for y'all who have signed up, you should be getting a recording of this later, later after everything has been processing. So give it about 12 to 24 hours there. And if any other questions for Serverless Guru, you can find us at serverlessguru.com, and questions for Benoit or both of us, feel free to, hit up Benoit on his Twitter or his website. And until then, until the next time we get to talk about AppSync and single table design, we will sign off. Thank you so much for attending today.
Yeah, thank you. Bye.
Bye-bye.